Hey everybody. I was in a live earlier on today, and there was an individual that says that sundials only work on a flat Earth. So here is a video. I've got a video that shows how the sun actually works, or at least we're calling it a horizontal sundial actually works on a globe. Changing every 15 degrees. The shadow hits every 15 degrees there. So this is an equatorial, a horizontal sundial. And horizontal sundials have their ticks get lower and lower and lower. So it starts out big and then gets smaller and smaller and smaller and smaller, and then gets bigger and bigger and bigger and bigger. So this is how a horizontal sundial would work on a sphere. And just by changing it to 15 degrees, you can see it went from solar noon to right there, the shadow's hitting 1 o'clock, and then so on and so forth. Changing another 15 degrees, you can see how the shadow's hitting 2 o'clock. So to do this on a flat Earth, and we're talking about, on this one though, we're talking about an equatorial sundial, which is what flat earthers try to use on the flat Earth. So showing what an equatorial sundial would look like is it's basically a stick up in the air that is perpendicular to the flat plane, right? So let me see if I can get it, just to kind of show you sideways view here. Where is it at? There we go. So there's that perpendicular stick. And so what we've done is we've taken a flat Earth model, and this is on the equinox, so this is at the equator. And what I did is I moved the sun every 15 degrees. So on an equatorial sundial, the shadow moves over 15 degrees, and you can see that. So let me pull up what an equatorial sundial looks like real quick. Just so you guys can see. So equatorial sundials have their markings every 15 degrees. Right. So, well, this one's an equatorial, but it's angled, and the angle matches the latitude that you're at. Right. So all equatorial sundials will do that. But if you were going to take and use one of the basic sundials that the flat Earth uses, we would look at it in this regard. And here's the problem. So since we have these suns at every 15 degrees, right, they're rotating around the central point. So from here to here is 15, 15, 15, and 15. So this is solar noon. So what I'm doing is I'm simulating a shadow line. So this sun hitting this point, this would be where this shadow would be showing solar noon from my location. Now, if I move 15 degrees over, so 15 degrees per hour, now that I've got this is at 11, so we're going back in time here. So this is at 11 o'clock, and then I pointed directly at that sundial. Now you can see that there's the beginning of the angle, right? So there's the 12, this is the 11. Now when you go back in and you go to the 10 o'clock, this is the angle from 10 o'clock, and you notice that the angle is actually smaller at that location. Now when you go to 9 o'clock here and do another line, and you notice again, the angle changes again. So this is 12 to 11, and 11 to 10, 10 to 9, 9 to 8. So it's doing a couple things wrong here. One, it's not giving us a constant angular size of 15 degrees per hour because of its rotation is not correct. And two, it is actually doing the exact opposite of what this sundial is actually doing, with it actually getting all of the lines closer towards noon. On a flat Earth, all the lines get further away or closer in the opposite direction, or further away as it gets closer to noon, per the orbital path of the sun in the sky. Again, every 15 degrees, we're going to hit that line and mark it. So if you were to do this on a flat Earth, this is what your markings would be on the ground. Now, the reason why this is not correct is because, one, the equatorial sundial should be facing at an angle at the same latitude as the person is, and two, it should be doing 15 degrees per hour. So this is a very simple way of showing how a flat Earth can't make a 15-degree hourly sundial, because as it gets from this long position here to this short position here, your angle variances are changing. The only way that this would work is if the sun was equally at all 15-degree increments away from the point of the observer on Earth. So it has to be, the sun would have to be at the same distance away from the observer. Now, doing this, what flat earthers will do is they'll do it up here, right? Because the sun is the same distance from the central point here, every 15 degrees. So just all these lines, these longitude lines are 15 degrees. So yeah, it would work just fine from the North Pole. But when we use our sundials, we use our sundials from our origin, from our location. And that's where it just totally messes up in that regard. So when you see a flat earth, they're talking about how sundials work on a flat earth, they're pointing at here, but we don't have all of our sundials at the North Pole. We put the sundials where we're at to test our time, to show our time. And this doesn't work because the angle deviation here matches the angle deviation there. So I hope this helps. If you got any questions, let me know. Hope you guys have a great day. See you on the next one.